In the field of science and highly regarded bits of knowledge regarding what existed early on to the gigantic effect, there have been mixed discussions and captivated characters for a really long time. This Goliath demand tests more than just how we could unravel the universe, it challenges the veritable farthest imaginable goals of human information. Standing at the edge of existence, we examine the extensive shadowing and consider the possibilities before us. The universe was planned for the event of the Big Bang, which denoted the start of history, space, and what we know. In any case, there was a moment sooner. Ahead of time, was there, in the end, a state of nothingness, a calm before the ranting gathering began? And if this is so, was it real, or was there something else, something essentially more alarming, that existed before time itself? As we delve further into this question, science takes us on an excursion beyond the cosmos, into contemplations that challenge our understanding. Physicist Brian Cox, recognized for his dedication to the wonders of the cosmos, suggests that something stunning could have existed before the Big Bang. He moves us to reevaluate our understanding of reality and existence. In this assessment, we'll explore the hypothesis and the science, the amazing insider secrets that could determine what existed prior to everything. We'll examine theories such as cosmic inflation, quantum changes, the multiverse, and dark energy. The solutions we discover may very well astonish you, yet they could also open new understandings of our place in the universe. Prepare to dive deep into a world beyond imagination and science, where the shadows continue to circle, leaving researchers stunned and sometimes even perplexed. What existed before the Big Bang? To appreciate what might have existed before the Big Bang, we first need to understand what the Big Bang actually was. Astronomers claim that it was the moment when the universe became incredibly hot and dense, rapidly expanding to initiate the formation of all matter, energy, and fundamental forces. When we look toward the night sky, we see evidence of this hot beginning, with galaxies fanning out from a central point. But what caused this to happen? Was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or calm. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like an inspiring vacuum. However, this vacuum wasn't completely empty. It contained a massive amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, occurred so rapidly that it essentially set the foundation for everything that would happen next. In a fraction of a second, space expanded at unimaginable rates until the inflation slowed down, and the stored energy transformed into the particles and forces we associate with the Big Bang. But what was the nature of this energy? Why did it suddenly appear and trigger the birth of the universe? And why did inflation stop? Scientists believe that this limitless expansion created patches of the universe, each experiencing its own Big Bang. Imagine a cosmic fabric continuously stretching, with tiny air bubbles forming, each bubble representing a separate universe, including our own. This concept, called the inflationary multiverse, suggests that there may be countless Big Bangs and an infinite number of universes. This enormous and mind-boggling idea challenges our understanding of the universe and raises a fundamental question: what else is out there? The idea of nothingness. Does nothingness truly exist? Based on our current understanding, even if you removed all energy, particles, and radiation from the universe, it still wouldn't be completely empty. Darkness may fill the void, but matter, quantum fields, and dark energy would still be present, forces we have yet to fully comprehend. Even in its most seemingly empty state, the universe's structure persists. In fact, removing these forces and creating a truly dead space would still result in the spontaneous generation of new energy. This puzzling reality suggests that absolute nothingness may be impossible within our current comprehension of space. Imagine creating a region with absolutely no particles, no radiation, and no negative energy. Even then, quantum fields and fundamental constants would still exist, indicating that even nothingness has properties. One such idea is zero-point energy, which represents the lowest possible energy state of a quantum system. In this state, quantum fields can still fluctuate, causing particles to briefly appear and disappear, making the concept of a true void almost impossible. This directly challenges our understanding of nothingness and suggests that even before the Big Bang, something must have existed. The eternal inflation hypothesis. One of the most unexpected hypotheses in modern cosmology is the idea of eternal inflation. If inflation created our universe, could it be possible that it has been occurring indefinitely? Brian Cox describes a scenario where incredibly high levels of inflation continuously generate new universes. Imagine each Big Bang as a flash of light, occurring in different regions of an ever-expanding multiverse. This suggests a fractal-like universe, where each new universe may create its own Big Bang. For scientists, this hypothesis is both thrilling and unsettling, as it implies an endless multiverse with no clear beginning or end. Imagine our universe as just a single speck in a vast cosmic network, continuously spawning new universes. If this is true, what if reality has no before or after, but instead follows a recurring pattern of universe formations? Quantum fields and the nature of reality. Our understanding of nothingness also changes when we consider quantum field theory. According to this theory, the universe isn't just empty space with scattered matter. Instead, it consists of vast, interconnected energy fields that define the nature of everything. These fields are like invisible oceans, with particles acting as waves. Even at their lowest energy state, known as the vacuum state, they remain active, allowing particles to spontaneously appear and vanish. This leads to the concept of virtual particles, which exist momentarily before disappearing, leaving behind only a trace of their presence. This idea challenges our traditional notions of reality. If a universe could exist where absolutely nothing was present, no matter, no radiation, no energy, would it truly be empty? According to quantum field theory, the answer is no. Even in a vacuum, quantum fields remain dynamic, creating temporary fluctuations that defy our concept of emptiness. This suggests that the universe never truly had a state of absolute nothingness. Dark energy and the expansion of the universe. Dark energy is one of the most mysterious forces in cosmology. Currently, it is responsible for the accelerated expansion of the universe. But could it also have played a role in what existed before the Big Bang? If dark energy was present before the Big Bang, it might have influenced the conditions that led to the formation of our universe. Some scientists speculate that fluctuations in dark energy could have triggered inflation, setting off the chain of events that eventually led to the Big Bang. The role of dark energy in cosmic expansion. Dark energy remains one of the biggest mysteries in modern physics. While we know it is responsible for the accelerated expansion of our universe, its true nature is still unknown. Some scientists suggest that dark energy could have existed before the Big Bang, influencing the conditions that led to the birth of our universe. One intriguing possibility is that fluctuations in dark energy caused the rapid inflation that set off the Big Bang. If true, this would mean that the universe did not emerge from complete emptiness, but rather from a pre-existing energy state that eventually transformed into what we recognize as space and time. If dark energy played a role before the Big Bang, it could mean that the universe was never in a true vacuum state. Instead, it might have existed as a primordial energy field, waiting for the right conditions to trigger inflation. This challenges the traditional view of the Big Bang as the absolute beginning of everything and raises new questions about what came before. The cyclical universe. Was there a universe before ours? Another fascinating idea is that the universe did not begin with the Big Bang but is part of a cyclical process of expansion and contraction. Some physicists propose that the universe undergoes endless cycles of Big Bangs and Big Crunches, where each universe eventually collapses into a singularity before rebounding into a new expansion phase. This theory, known as the cyclic model, suggests that the Big Bang was not the true beginning but merely one event in an infinite series of cosmic rebirths. Evidence for this idea comes from certain interpretations of string theory and quantum gravity. According to these theories, spacetime may have a deeper structure that allows for universes to collapse and restart without losing information. If this is correct, our universe might carry traces of a previous universe that existed before our own. One prediction of the cyclic model is that remnants of past universes could be imprinted in the cosmic microwave background, CMB, the faint radiation left over from the Big Bang. Some scientists believe that subtle patterns in the CMB could reveal clues about a pre-existing universe, providing evidence that we are part of an eternal cycle of creation and destruction. Could our universe be a simulation? Another radical yet thought-provoking idea is that our universe might be a simulation, a vast and intricate creation by an advanced civilization. This concept, often called the simulation hypothesis, suggests that what we perceive as physical reality is actually a complex computational process. If an advanced civilization had the capability to create entire simulated worlds, it is possible that our universe is just one of many artificial realities. Some physicists have explored whether the laws of physics contain patterns that resemble computer code or artificial constructs. If such patterns exist, it might suggest that the universe was designed rather than naturally occurring. If our universe is a simulation, then what existed before the Big Bang? In this scenario, the before could simply be the system that created the simulation, a level of reality far beyond our comprehension. This would imply that our universe is just one of many simulated worlds, and the true nature of existence lies outside what we can observe. The search for answers, what comes next? As we continue to explore the origins of the universe, science pushes the boundaries of what we know about existence. Whether through cosmic inflation, quantum fields, dark energy, or the multiverse, one thing is clear: the story of the universe is far more complex than we once believed. Future discoveries in quantum mechanics, astrophysics, and cosmology may finally reveal what, if anything, existed before the Big Bang. Whether we uncover evidence of a previous universe, a multiversal reality, or a deeper structure of space-time, these discoveries will fundamentally change our understanding of reality. For now, the mystery remains. But with every scientific breakthrough, we move closer to answering one of the greatest questions of all time. Where did we come from, and what came before us? Anyway, did dark energy exist before the Big Bang? According to some perspectives, the fact that dark energy exists today is a delayed consequence of an energy field from before our universe's development. Dark energy's properties imply that a monstrous, mysterious force could have existed in some form before the Big Bang. Some theories suggest that dark energy, in a much more powerful state, could have managed the inflationary phase, resulting in rapid expansion. The presence of dark energy suggests that, whether our universe was emptied of all matter and radiation, this force would continue to develop. This idea came from the outer space-time layer, leading to a disturbing question. If dark energy was present before the Big Bang, could it have eventually formed the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not just as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another hypothesis is that cyclic cosmology offers an alternative to the Big Bang as a definitive beginning. According to this theory, the universe goes through enormous birth-death patterns and renewal. In this model, the Big Bang is not a one-time event but rather part of an undying cycle where universes form, collapse, and rejuvenate in another cycle. This theory suggests that our universe could have been restored from the remnants of an earlier universe. The process of compression and expansion in a cyclic pattern would mean that there was never a true beginning, rather, an eternal series of universes emerging and renewing themselves again and again. Cyclic cosmology raises significant questions, as it suggests that time itself could repeat rather than continue. If this hypothesis is correct, it could mean that what existed before the Big Bang was essentially another form of the universe, one that only collapsed to give rise to the universe we currently have. For scientists, this theory offers a compelling answer to the problem of extreme origins, suggesting that there is no clear beginning and that the universe has always existed in some form, transcending our concepts of time and existence. Gravitational waves are another intriguing phenomenon that could shed light on what existed before the Big Bang. Discovered in 2015, these waves are ripples in space-time caused by extremely massive objects, such as black holes or colliding neutron stars. These waves can travel great distances, carrying information about the events that created them. Could gravitational waves provide insight into the creation of the universe? Some physicists suggest that gravitational waves from before the Big Bang might offer clues about the state of the universe prior to its birth. Gravitational waves initiated by inflation in the early universe may leave traces that could help determine whether the Big Bang was truly the beginning, or if cosmic events occurred before it. These waves could be remnants of events beyond our usual understanding. Their presence might also imply a greater structure beyond the one we are accustomed to. If analyzed correctly, these dim signals could reveal insights that transform our perspective, much like how we uncovered the origins of the Big Bang. Consider the possibility that they show the faint traces of a past universe or an event that occurred before the Big Bang itself. As researchers continue to explore the depths of space, the question remains, what existed before the Big Bang? With current theories emphasizing quantum mechanics, multiverse, and cosmic expansion, it seems we are closer than ever to unraveling the deep secrets of the universe's beginnings. While the complete answer remains elusive, our understanding continues to evolve with each new discovery. As we explore these hypotheses, we can also consider how they may fit together to illuminate the broader picture, the true essence of existence itself. But until then, we are left with the mystery, driving science forward and venturing into unknown realms far beyond our reach. Clearly, our understanding of the universe is constantly evolving. One critical area of investigation involves the relationship between existence itself and time as we experience it. Time may not have existed in the way we understand it before the Big Bang. Some theories propose that time itself began with the Big Bang, making it impossible to trace what came before it. This idea challenges our fundamental concept of reality, suggesting that the question of before may not actually be relevant when it comes to the origins of the universe. Recent advances in quantum mechanics have sparked new ideas about the nature of reality. One particularly captivating concept is the possibility of a quantum vacuum, a state where, even in the absence of matter, the universe is not truly empty. Instead, it is filled with fluctuating energy fields that can give rise to particles and forces. These quantum fluctuations could have played a crucial role in the formation of the universe, potentially providing the essential conditions for the Big Bang to occur. This raises the question: did the universe emerge from a quantum fluctuation, or was it somehow triggered by these fluctuations? Another fascinating aspect of pre-Big Bang theory revolves around the idea of cosmic recycling. In cyclic cosmology, the universe undergoes an endless series of expansions and contractions. After each Big Bang, the universe would ultimately contract back into a singularity before expanding once more. This cyclical process could mean that the current state of the universe is just the latest iteration in an eternal series of cosmic births and deaths. Some scholars propose that each cycle could produce slightly different outcomes, with the current configuration of the universe shaped by the conditions of the previous cycle. This idea challenges the notion of a definitive beginning, instead suggesting that the universe is in a constant state of renewal. The possibility of additional dimensions adds another layer of complexity to our understanding of what preceded the Big Bang. String theory, for example, suggests the existence of extra dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These additional dimensions could provide an entirely new framework for understanding the origins of the universe. The role of extra dimensions and the multiverse. If extra dimensions exist, as suggested by string theory and M-theory, then our universe might be just one among many in a vast multidimensional space. Some physicists propose that our universe could have emerged from the collision of higher dimensional brands, short for membranes, which could have triggered the Big Bang. This concept, known as the ekpyrotic model, suggests that what we perceive as the beginning of time was actually the result of interactions between pre-existing structures in a larger reality. In this view, the Big Bang was not the absolute beginning, but a transition event within a much grander, higher dimensional cosmos. This raises profound questions. What governs these higher dimensions? Are they eternal? Could they contain other universes that have already gone through their own cycles of birth and destruction? Multiverse theories also suggest that our universe is just one bubble in an infinite cosmic foam of universes. Some versions of this theory propose that new universes constantly form due to quantum fluctuations in an eternally inflating space. If true, then the Big Bang was merely the birth of our particular universe within a larger, ever-growing multiverse, where different physical laws and constants might apply to different universes. Quantum mechanics and the birth of the universe. Quantum physics provides another perspective on the pre-Big Bang era. One idea is that the universe emerged from a quantum fluctuation in an empty yet energetic vacuum. In quantum mechanics, even empty space isn't truly empty. It is filled with fluctuations where particles and energy spontaneously appear and disappear. If the universe emerged from such a fluctuation, then nothingness before the Big Bang might not have been true nothingness, but rather a quantum state beyond our usual understanding of existence. Some physicists, like Stephen Hawking, have suggested that asking what happened before the Big Bang may be meaningless because time itself began with it. In this interpretation, time was not something that extended infinitely into the past but was instead part of a curved, finite geometry, similar to how the surface of a sphere has no edge but still has a finite area. Another fascinating idea involves quantum gravity, which attempts to merge quantum mechanics with general relativity. If gravity had a quantum nature in the earliest moments of existence, then spacetime itself might have been in a foam-like state before stabilizing into the universe we observe today. Some versions of loop quantum cosmology suggest that instead of a singularity, the Big Bang was actually a big bounce, where a previous universe collapsed before expanding again into ours. The eternal nature of existence. One of the most mind-bending possibilities is that existence itself is truly eternal. If time did not begin with the Big Bang but has always existed in some form, then the question shifts from what came before the Big Bang, to what form did the cosmos take before our universe began? Could there be an underlying, eternal reality that constantly gives rise to new universes? Some versions of cosmic inflation theory suggest that our universe is just one phase in an ongoing process of cosmic creation. This idea aligns with the philosophical notion that something cannot come from nothing, implying that some form of existence, whether quantum, energetic, or dimensional, has always been present in one way or another. Searching for clues in the present universe. Scientists continue searching for evidence of pre-Big Bang conditions by studying the cosmic microwave background radiation, CMB, the afterglow of the Big Bang. Some theorists suggest that tiny irregularities in this radiation could contain scars or patterns left behind by events before the Big Bang, such as collisions with other universes or remnants of previous cycles. Gravitational waves, too, could hold answers. If we can detect signals from before the Big Bang, they might reveal the physics of an earlier state of the cosmos. Advanced telescopes and observatories, such as the James Webb Space Telescope, are pushing the limits of what we can observe about the early universe, bringing us closer to uncovering its origins. The mystery continues. Despite all these theories, we still do not have a definitive answer to what came before the Big Bang. Every discovery leads to new questions, expanding our understanding while deepening the mystery. As physics progresses, we may one day uncover evidence that revolutionizes our view of time, space, and existence itself. Could we one day prove the existence of other universes? Will we uncover a fundamental principle that explains the origins of everything? Or will the true nature of pre-Big Bang reality remain forever beyond our reach? For now, the quest continues, and each new discovery brings us one step closer to answering the ultimate question: where did everything come from?